So I'm going to cover a lot of territory, but I do want to just point out this very interesting postcard. So this is a postcard that has been to space and back during the Apollo era, and it was Apollo 15, and they brought up a little rubber stamp, and they canceled the stamp on the moon. And so you see that cancellation in the area where maybe there should be an address. So there is no address right there, and that's what I want to start to talk about. So think about an address on Earth. It has a particular syntax, and that syntax is based on roads and cities and states and zip codes. We don't have anything like that on the moon and Mars. So I wanted to do an address framework that was very intuitive, very clean, very simple. And so what I discovered is that there's a cartographic element called a quadrangle. And quadrangles just define regions on the moon and Mars and Earth. And some of them have names and some of them have numbers. So I just borrowed from the quadrangle and used a very similar syntax. And I'm using the named quadrangles in place of cities and states. I'm using the numbered quadrangles in place of zips. So what you're going to see is a planetary address framework that would be recognizable all over the world. So one of the other things you have to think about when you're charting a system of roads on the moon and Mars is, what should we name these roads? You know, do we want to name them for cartoon characters? What do we want to name the roads? And so rather than coming up with a set of nomenclature guidelines, I went and kind of explored how we name planetary features and how do we name planets and galaxies. And there's an international body called the International Astronomical Union, and this is mostly astronomers who are out there exploring and discovering things and coming up with new names, but they have a very stringent set of nomenclature guidelines. And so what I did is I just took a close look at how they're naming the planetary features, the landforms on the moon and Mars, and just kind of borrowed heavily. I didn't try to come up with a whole new set of nomenclature guidelines. And what I did is I just stopped at 32. I thought, you know what? I can't name all the roads on the moon and Mars. This is probably not up to me, but I will show you how we could do it. And so these would have to be U.S. roads because it's based on U.S. popular culture and U.S. astronauts and so forth. And so I stopped at 32 because there were 32 Apollo astronauts, and just tried to show sort of the range of possibilities. And one of the areas where I focused a lot was on what's it close to? Is it close to a crater? Is it close to something that already has a name? And so you're going to see a lot of planetary features up there. But also you're going to see sci-fi authors, you're going to see astronauts, you'll see fictional characters from sci-fi, and this is all based on how they do things in the IAU. So if we're really going to do this, if this is not just going to be a cute little novelty thing, obviously we're going to need some kind of oversight body like the IAU that focuses on how we name these roads and how we figure out where these roads should go. So the first thing that international oversight body should probably do is to adopt the Eskey system as a global standard so that we're all working with the same syntax, so we don't have a whole bunch of different planetary address frameworks all over the world. Then we want to define those nomenclature guidelines, and then we would need to coordinate across all the countries who wanted to get involved in charting their roads provisional names. We would need to identify where they want to put their roads and where they want their roads to start and end. And then I started to think about, okay, now let's imagine that we actually agree and we have an official map on the that globally we agree this is the map of the lunar and Martian roads. We're going to have to think about making those roads. And I saw a lot of literature out there about paving roads and using microwaves and 3D printing. Thought, oh gosh, if we do that, that's going to take a really long time. And what I found instead is that rover tracks, particularly on the moon, last forever because there's no wind and there's no atmosphere, and the rover tracks are probably sufficient for what we need because these rovers are four-wheel vehicles and they don't really need paved roads. So I came up with this idea of something called a road bot. And a road bot's only goal is to make a road. And the other area that I started to think about was space mining. So there's a big discussion now about how we can get up there and mine some of the natural resources. There's a new law that came out called the Space Act in 2015, and this basically says that commercial entities own the natural resources. So if you go up there and you mine the moon, whether that's water, ice, or something else, you own those resources. And so perhaps this concept of space roads or routes could define unofficial safety zones for the miners. These are our roads, this is where we're going to mine. So I have a long history of working with open source code and open data. I was at NASA Ames Research Center, and I was their web manager and got involved with something called Open Government. So because I like the idea of this becoming sort of a global entity, I thought that open source software might be our best bet. So we're using something called Quantum GIS to map the roads, and we're using public data sets and elevation models that are provided by NASA and USGS, freely available out on the internet. And this just talks about all of the standards that QGIS understands. It's a very robust system, and for our purposes, it was great.